Okay, so we've got a little Z80 system here. We've got a CPU, some ROM, RAM. The bus is a little bit abstracted. And the main thing to note here is that we have two Z80 peripheral chips that are capable of running in interrupt mode 2. They share a common int line, int, generating the interrupt to the Z80. Each device is an open drain output, which means it can only pull the interrupt low but not high, so you need an external pull-up resistor. And what we're going to do is we're going to, I'll get to this in a second, program the PIO with vector 0 and program the CTC with vector 1. Now here's what the code looks like for this system. At address 0, this is our reset code. We always have to set up the stack pointer if we're going to be using interrupts. We set up the PIO with all the various register modes as well as setting it to vector 0. And we set up the CTC with all the modes and operations we want, as well as setting it up with vector 1. Now, we will load the I register, the interrupt register, with 2, which will correspond to the MSB of the address of our interrupt vector table. Then we can turn on interrupts and our code can start doing its main stuff. Now, when an interrupt we want to handle through either the PIO or the CTC, we're going to set this up so that we have one interrupt at one address which will only handle PIO stuff. So at address 123 we've got the ISR. We're going to read some PIO registers, do whatever it is we need to do, then we're going to return from the interrupt. Same thing, we've got a separate ISR for the counter timer circuit, which is we're going to place at address 2345. In theory, we could also do away with mode 2 entirely and just use one single big fixed interrupt that pulls all the devices, but in theory it's faster to be able to immediately tell which device is going on. So what we have here in address 200, this is our table, which is basically just an array, 127 slots in the array of addresses. Okay, now this is slot 0 contains 1, 2, 3, 4, which is the address of this ISR. Slot 1 contains 2, 3, 4, 5, which is the address of this ISR. And inside this table, because these are 16-bit addresses, we have LSB MSB for 1, 2, 3, 4, LSB MSB for 2, 3, 4, 5. And so a 256-byte table can hold 127 slots. So now what's going to happen is when the PIO wants to interrupt, he's going to pull the interrupt line low. As soon as the Z80 acknowledges the interrupt line, he's going to indicate that on the bus, and the Z80 PIO is going to write a 0 onto the bus to indicate that he's requesting vector 0. Now the Z80 is going to go here and say, okay, my I register is 02. The vector I got was vector 0, so I need to read slot 0 out. And so he fetches 1, 2, 3, 4 out of the table memory and starts executing the ISR at 1, 2, 3, 4. Runs the code, returns, goes back to doing his main stuff, and now the CTC wants to interrupt. So the CTC now, when he interrupts and the Z80 responds, he picks that up off the bus pins and says, aha, interrupt acknowledge cycle. Now he throws a 1 onto the bus. The Z80, as part of his interrupt processing, now he reads the 1 off the bus, combines that with his I register and says, okay, I need to go to slot 1. So that's address 202. That's just the vector number shifted by 1, or put the vector on the high bits of the bus. And the 2, 3, 4, 5 is the address he reads, so he executes this ISR, goes off, returns the code, and then goes back to doing his stuff. So that's basically what happens in mode 2. You get some chips that may be able to handle multiple channels. I think the SIO has multiple channels, and so what it can do is you can set it up with a vector that is on an even alignment, like a mod 8 or a mod 16 or a mod 4 boundary, And the chip, if you program it to say use vector 8 and it's got 2 channels, it'll automatically pull slot 8 and slot 9, putting those numbers on the bus to indicate whether it's a channel 1 or channel 2 from that particular peripheral.